Hey guys, welcome to the first devlog for C. Um, so this is going to be a bit different of a video. It's mostly going to be me talking. There's not going to be that many good visuals, but I'll try. And it's not going to be really scripted, so it might kind of get boring at times or not make sense. It's definitely not going to make sense to a lot of people. But basically what this series is it's me talking about my programming language called C, spelled S-E-A, like water. Yes, I'm aware that that is a horrible name and it adds to confusion, and that's part of why I'm keeping it, to be honest. So, I don't even know at this point, 2 or 3 years ago, I was really into Python and Python coding, and I really was interested in the syntax, and I thought, C is like a really cool language, like the letter C. It's a really good language. It's kind of a nightmare to use. Like anybody who's ever used C, especially if you try and do like string manipulation stuff, compared to Python, it's like just a nightmare. So I had the idea, well, what if I just made my own version of C, but with like Python like syntax? And that was the original idea. And the first sort of step I took was learning how all this worked, which is actually the foundation of my tutorial that I made on how you make your own language. All of that comes from this guy, who's also named David. And he had a very interesting, just little tutorial series. I'll link this in the description if you're interested in checking it out. It wasn't perfect. I mean, he did the thing that's very common where you kind of have all your code in like one tall file, which I really don't like. I'd rather just split it up. But overall, he did a good job of explaining it conceptually, and it allowed me to get started making my own. And that brings us to the first legacy repository here with 255 commits. In fact, it might be more, 257, because I started reworking stuff. But this is the original repository, which I wrote my language in Python. I was very ambitious initially. This first section of the video, by the way, is mostly going to be the history of C. So I was very ambitious at first. I wanted to make a transpiler, which is like a compiler, but instead of compiling to assembly code, it would compile to C. I want to make an interpreter, and I also want to make an actual compiler and learn assembly and all that. And just like Python, I wanted to have like a terminal interface. That ended up being a lot of work, and I kind of got it working, and there were like a lot of commands and stuff, and I used, what's that library called? There's some like very common library. I'm just curious. Let me see. Curses, right? The curse interface. I actually ended up getting that working pretty well, but there was a big issue. The biggest issue with this version of C, this very early version, well, there's a lot of issues, but the biggest one was parity between the interpreter and the compiler. And the transpiler. The issue is, I wanted C to behave consistently, no matter how you used it, right? If you use the interpreter or the transpiler, the code should be exactly the same. But the issue is, the transpiler is limited by C, the original C language. It's heavily limited by that. So I'd have to make my interpreter completely dependent on C. So it's like it wasn't that great of sort of like a plan. And I ended up realizing, and this is going to become a common thread, I reach a point where I just decide it's probably better if I just restart from the beginning, because I've learned so much that I can restart it. And if we just look at the grammar initially that I had, this is very much like Microsoft's C language syntax. If I look, God, there's so many of these. This is like C's grammar based on like how Microsoft would define it. And mine is essentially word for word the same grammar. I didn't fully understand what everything was, but I added in essentially most things. But you also see I added in some Python things. For example, the size of operator, I split into two operators, just two keywords, because I thought that's like more readable. Yeah, I have like the familiar sort of operators. I changed casting to look more like Python and stuff. Overall, this grammar was pretty bad. There's some things I've kept, like a lot of these Python things. But for example, all of the assignments are expressions, which means in C, if I just quickly type, if you if you like say A is B, then that is an expression that you can just take the value of. Hopefully I didn't show anything in that search thing. Yeah, so assignments can be expressions in the original C, which honestly is something I've gotten rid of mostly because it's just kind of confusing when you're modifying values inside of expressions. So that should bring us to the next compiler, which went pretty well until I started adding arrays. But you notice in the last one I had .he files, .hea, which are like header files for this. But I got rid of those because the biggest issue with C, other than the syntax, is having to like add header files and manually link things instead of having like an import system like in other languages. Clearly, so something I gave up on was the idea of an interpreter and the idea of like a actual compiler. What I decided to do was strictly transpile into C and then go from there, and I can just compile by using that. And I've stuck with that because I just think that's like the best way for me to do that. There's no reason to like reinvent the wheel. And I don't have the skills. I haven't found a good tool set to learn assembly from that isn't like a big textbook. There's not like good videos. Maybe I'll make those if I ever figure out how it works. Let's take a look at what the grammar sort of looks like at this time. And I was like beginning to rework it, and I split it up into sections. So for example, I added like a norm operator. I wanted to do like single ones of these because it would be like an absolute value. But it was kind of hard to parse, so I did a like double to be like a norm. I also have like list sort of syntax like in Python here. And you can also see like the true false is capital, just like in Python. And there's a lot of other stuff in here, and this is mostly trash. But this is where I started like changing up. I'm like, I kind of like the way Kotlin does casting, and this is where I learned about Rust as well. And initially I just wanted to replace the syntax of C, but then I started thinking I could do better and try and improve. For example, like I also replaced the %mod with the keyword mod because that tends to be more readable and less confusing. In my current version, I'm doing that, but I'm still allowing you to use the % because people are going to be familiar. Now, this is a hill I'm totally going to die on, but I changed XOR from a caret to a $sign. Now, this is for two reasons. One, I think caret should be reserved for exponents because that just makes the most sense and that's what people expect. But also, XOR is very similar to OR, and the $sign is like the vertical line, but with like some squigglies, sort of like how the and is a bunch of squigglies. So it's almost like an in-between sort of thing. It matches better to me than just the caret. And the historical reason why it's a caret and why these are all these symbols is just because they were added like later and they needed extra symbols and stuff for them. So as far as I'm concerned, they're changing them's not that big of a deal. I also began to implement the ownership memory model from Rust, and that's where this unary $sign is going to come in as well. But this version overall was pretty bad. I also, you notice, added default arguments to like function calls and stuff. This was going pretty well, but my whole thing is to try and remake C without adding like significant runtime cost. If you use my language, it should be essentially as efficient in terms of runtime as C. That's the whole point, because if you're okay with adding a tiny bit of runtime cost, you should just use C++ or some other language like Rust. The reason people would still use C today is because it needs to be that low-level, pure performance type language. So if mine is to exist at all, it needs to still mostly be that. So most of the syntax has to just be helpful rather than costly. Like it has to be sugar, like syntactic sugar, where it just replaces something that's more complicated rather than actually doing something more complex. And so, for example, you'll notice if I look in these files, I'll have like a file per expression, and I've split them up by nodes. I think in this one, I really got the like lexer down pretty well. But I started adding arrays. And the big issue with this was I didn't want, with the ownership memory model, I wanted it to behave like Rust, where, well, not exactly like Rust. I wanted to try and automatically allocate things on the heap as necessary so that the programmer wouldn't have to care. But the issue is functions. Because if you pass in a pointer into a function, that function has no idea whether that pointer is allocated on the stack or on the heap or in the data segment or somewhere else in memory. And so I tried getting arrays to work and figuring out if they could just be on the heap and like copying them and stuff, but it ended up just not being good enough. And at this point, I'd been programming in Python so long, I wanted a bit of change of pace. And like before, I felt if I restart, I can do a lot better. So I rewrote everything in C++ because I wanted it to be a lot faster. And faster it was. When I ran the Python version, it would take maybe 2 seconds to compile a file. And the C++ version was essentially instant after compilation when it ran. Now, if I go to the CPP branch, the code was pretty good, but there's a lot of issues. Let me just see if I can find any good examples out of nowhere. Maybe if I go into like my lexer. I had to define my own like in sort of method to make it more like Python. And there were a lot of issues with that. And I used like default arguments for things, but it ended up being cluttered because you have to provide every argument when you call the function in C++, even if there are defaults, which is very annoying. Not to mention having to manage my memory myself and having to use pointer syntax for things and make sure that there's destructors for all my objects. But honestly, the biggest issue with C++ for me is the fact that every single one of my source files, if I look in my parser, you'll see just like how many I have. Like all of these CPP files in all of these folders need an accompanying header file in the include, which is just a nightmare. Having this many files and 2 of the same for like no reason, and then having to manage references and pointers and stuff. It worked and it was okay, but it's just, ugh. It was so unmaintainable. And I reached a point where you see there's a few stages here that I had. The first stage is the lexer, which breaks a source code file into a list of tokens. You'll be familiar with this if you've seen my tutorial series. Then I had a substitutor, which essentially just replaced some like sets of tokens. So can I even see anything in here? No, I need to go to the source file, not the header file, I think. If I go into the substitutor, you see, for example, if I have... None of this is that readable, if I'm being honest. I guess I did write it out in the docs, though, so I can just take a peek at that. Like I said, this video is not very scripted. So I had just a few expressions, so you could have like a range expression. And the way I did that was, instead of like making a range object, which would cost something, I would just replace the tokens with like other tokens separated by commas, as if you entered them, but it just saves you having to type it. Sort of like a macro in C. And then after substitution happened, then the tokens would be parsed into a syntax tree. And then, in order to make my system work, I wanted a publishing step. And now what the publishing step is, if I have to go back to my grammar again to show you statements. How my import system works. It's very similar to Python. You can specify lib if you want to import specifically like a library. You can also use includes in this version, and you can like directly use C code in this code. I have like C blocks for that, a syntax where you can just enter C code. because it transpiles to C, so I could just like copy paste your code. But basically you can like import from a file, and you can import the entire file, and in which case, if you import the entire file, then you can use the like : syntax, like in C++, like the C++ namespace syntax, but that solely exists for files. So you can specify like from this, it's in this file, : this object in that file. Or you can import them with a name. You can import everything, and if you import everything, or if you import the file, then you just have to use the like : syntax. Otherwise, you just like use the identifier, sort of like in Python, except instead of using dot for like your module or whatever, you're just using : for the file name. You can also just, you can import from, or you can just import like the file, and you can also change the name of the file if that's your goal, if there's like too many things that are named the same or whatever. And it's kind of a mess, but it's okay. It's a pretty decent import system. So the reason, okay, back to the publisher. The whole point of a language like mine is doing a lot more safety checks. So I want to be able to know what every function is, what they return, what they take, all the types and all the information, even if it's in a different module. So what the publisher has to do, not only that, but I want like function overloading and function hoisting. So not only that, but I need the publisher to go through a file. It needs to check ahead of time if it needs to look for every declaration and make a list of them. That way, suppose function hoisting, if you use a function before its declaration, that should be allowed. But it needs to verify that that exists in all of its data and stuff. So what it does is it goes through the tree one time, one pass through the tree to get all the declarations, then a second pass to actually transpile, where it has the list of all the declarations, all the exports to other files that you can then import. And then it can check against that list before it transpiles all the files and stuff. That's my current idea for this. But I just couldn't find a way to store like type information, because the issue is, I should actually go into declarations. The issue is this version of C is very similar to C. God, I love how horrible the name is. This is something I've kind of stuck with for a while, which is make the unsigned types their own types. So, for example, integers are exactly what you would expect, but naturals, like the set of natural numbers, it's sort of more mathematical. Naturals are just unsigned integers, which kind of makes sense. And then I have reals to talk about floating points, because like the set of real numbers and then the set of complex numbers. I kind of like that naming scheme because it's a bit more math. Now, when it comes to sizes, this was kind of hard for the naming, because in C, this like an int 16 isn't precisely going to be 16 bits. It's going to be like at minimum 16 bits or something. It's like at minimum it can hold an integer in that many bits or whatever. And the real 64 is even weirder, because the like long double isn't actually like always 64 bits. It's like 100 or 80 or whatever. But basically it's just saying it's bigger than the normal one. I also was going to add like async functions and stuff. Now, there was something I was like on a thing and then I forgot. But there's a lot of very interesting decisions I've had to make. I've had to read through the actual grammar of C so much. But yeah, the big issue is this is so similar to the actual grammar of C. So you can have like arrays and arrays of pointers. And see, I actually, in this case, I reserved this for the caret for the pointer symbol. Because then it's sort of like you're saying it points to this thing. And then I use the at symbol for the dereference operator to be like the value at this thing. Because to me, that's just more intuitive. And overall, it doesn't really matter what symbols you use. You'll get used to them. But I think for people first learning, the point made sense for a pointer, and then like an at for a value at. I think both of those were kind of intuitive and pretty good decisions. But the issue is these types can just be so complicated. So recently what I've decided to do is start again. But this time in Kotlin. And now why Kotlin? It's mostly just, it has so many of the high level features of a language like Python, and the syntax is so clean, but it's still very performant. People underestimate the efficiency of Java because Kotlin is just Java. It's running in the Java virtual machine. It's the same thing, essentially. The JVM is incredibly efficient and performant in a lot of situations. Sometimes it can beat handwritten C++ code, but oftentimes it won't because, of course, you know, compiled code is still going to be the fastest. But in terms of an interpretive language, like a Java-based language is like honestly pretty good for performance. So this will still be leagues faster than Python. At least last time I used like 3.10, they may have, I know they've been making a lot of improvements recently, but even then, I kind of do prefer the syntax of Kotlin at this point. It's just really nice. I mean, look if I can give an example of sort of like you don't, semicolons are optional and white space doesn't matter. Initially, a long time ago in C, white space did matter and it was very much like Python, but since then I've gotten rid of that and I made it much more like Kotlin, where you don't need semicolons everywhere, but you can use them. And otherwise, if there's just like a new line, it's treated like a semicolon, but most white space just doesn't matter. I've also moved to have things like this where the types come after. But I very much like Kotlin syntax. And I thought F strings in Python were like the peak, but honestly, this like string, what would it even be called? Like formatting or interpolation or whatever. Syntax in Kotlin is like fantastic. It's just so simple. And it's very similar to Bash, but it is just simple. And I really like that. I also like the fun keyword for functions. It's just like tiny, but it makes more sense, obviously, than like a def for define, because that you could be defining anything. Val and var for like values that are immutable and vars that are mutable. I'm also going to use that. Now, I'm still in the early process of making this version of Kotlin, but I really just wanted to make a video out here to discuss it. I've also changed how I've written up the grammar, so it's a bit just more condensed. So this is not complete yet, but here's the like file identifier syntax I was talking about before. You'd have like a file name, : the thing you're importing. And you'll notice I'm also using a lot of Kotlin's like null safety features. So like checking if something is null before you access it. And this is nice in Kotlin because it can prevent having to check for like null pointer exceptions. But this is kind of even better in C because if you like access like a null pointer in C, like things just go bad. You just get like stack overflows or like you just get crashes, random just errors at runtime instead of actual exceptions because of course exceptions are expensive. So even though this won't prevent that, it will certainly help. It will just be a tool that developers can use to avoid it. Now I brought back the $ for the ownership model again, because the last time I redid this in C++, I didn't have ownership. I just had you allocated stuff, but I had like operators for allocating and stuff, so it wasn't as bad, but now I'll have $ for ownership, ampersand for references. I have % and mod both here because personally I'm going to use mod like most of the time, but there's no reason to not allow people to use %. Honestly, plus I still have % equals as an assign operator because of course I'm not going to use like the keyword mod. I'm still keeping my $ XOR because I just prefer it. Now I've also added an XOR keyword as like a logical statement. And you also see this other like null coalescing expression straight from Kotlin and this conditional expression from Python. Now, these logical statements are actually so interesting, the way I'm going to do them. So there's something very important to know about C. When any value that is not 0 is considered true. So my OR operator could simply, if I did like 6 or 1, This could simply return 1, but actually what I'm going to do is I'm going to return 6. Rather than check directly like an OR value, what I can return is something along the lines of, it would be like this. Is 6 non-zero? If it is, return 6, otherwise return 1. And this is kind of equivalent. It's sort of what Python does, because in Python, if something is none, if you say none or 5, for example, the value of that expression is 5. But the value of like 6 or 7 is 6. So the reason I can apply this to these. So if you do an argument, if you do something like this, instead of getting a true or false, some of the time you can preserve the value. And that could be very useful as shorthand, because otherwise you'd have to do like a ternary. And most of the time it'll be pretty efficient, I think. I might have to cache the value or just like copy paste in, and you may have multiple calculations, which isn't ideal, but overall it should be okay. I'll find a way to do it that's good. I'm okay with making like a temporary variable or something, I guess. I don't know. I haven't figured that far away, but that's sort of an interesting thing where it's like, it's just going to do that instead. Now, there's one big thing I've most recently sort of decided on. If you see the types down here, one thing I really like about Kotlin is that all the types are capital, and that's a result of Java having all their classes be capital, all their primitives are lowercase, but in Kotlin, you don't actually have those primitives. You just reference the class because it's essentially the same thing. So I'm just going to use that for the naming. I'm also going to add back an imaginary type, which I had back in the day. The reason for this is if you want to talk about an imaginary, a complex number in C is actually like twice as large. It's 2 floats back to back. But if you only want to talk about an imaginary, there's no reason to use 2 floats. And you could use real, but then it feels disingenuous if you're like, this is the real complex value, but what if you want to enter like 5i or something? And that's another thing I'm changing. In C, you use j for the imaginary constant because of engineers, but I'm going to use I because of math. And don't worry, it's not going to prevent you from using I as like a name as a variable. It's just if there's an identifier I next to a number, it's going to be interpreted as the imaginary type, because you're never going to just have a number followed by an identifier in the normal syntax. So yeah, the types will be capital. The imaginary is internally going to be a real. It's just going to be a single double, but it will do some like safety stuff. And there are no pointers. I'm getting rid of pointers. But for example, then I have to add like array types. So you have an array of something. Now, part of the issue, actually the big issue with the arrays last time, God, this is such a horrible unscripted video. If you're actually still here, that's very impressive. Maybe you just like listening to a crazy man ramble. One of the big issues with arrays last time was not knowing the size inside of a function. So what I'm going to do is I'm going to make arrays have a fixed size at compile time. It just has to be known at compile time. Now that's going to be a bit of a pain because you're going to always have to give an array a size. But the idea is you shouldn't be using arrays unless you really need to. So if you're in like an embedded system, you can use an array and just give it a fixed size. Now, one thing I don't think I'm going to do is VLAs. Like, I just don't see the point, honestly. Like, I understand that it can be very useful and stuff, but what I'm going to say is give the array a size. And if you don't want to do that, then use a type like an array list or something. Just use a more complicated sort of type. And so since making 2x2 arrays is very frequent, I'm going to make like a matrix type, which just simplifies the notation and stuff. But you also notice I'm using like this sort of notation. Now there's one big thing that I've sort of come to here. You see I've also gotten like public private. Val and var. What I'm going to do is make 2 extra pieces of information attached to every type. The way variables are going to work in this language is every variable is essentially just a pointer. Kind of like Java. Like, I don't really like Java, but I like a lot of aspects of it. Like, Kotlin to me is the best version of Java, at least the ones I've used. I haven't checked out like Groovy or Clojure or whatever. But I like sort of the idea that when you declare like an integer, you're sort of saying there can be an integer in here. It's like, it's just an int pointer essentially. And you can give it a value. Let me see if I can go back to like my ideas. I don't think it's in here. That's older. I think it's in my tests. Here. So you can declare like a value a, and it's of type #int. Now, if you declare it of type int, it just means it's an int that's not on the heap. Because what I mean by not on the heap is it could be in stack, but you could also declare it static and it could be in like the data segment of memory. Or maybe you could use the register keyword or something. I'm going to use hash to denote the heap memory. I was going to use a keyword dynamic, which I think looks good, but it's just too long. And if you're talking about like function arguments and you have to write dynamic all over the place, it's going to be way too long. And that's one of the big issues with Kotlin and Java is function arguments just take up so much space because it's so verbose. So I'm going to use hash to define an int. Or I'm going to use hash, I mean to define a heap value. And I'm going to keep the type sort of separate. Then I'm going to use, just like in Kotlin, the question mark syntax to allow a type to be nullable. So by default, this like b is like a pointer to an int. Specifically, it can only point to an integer that is not on the heap, and it can never be null. You're not allowed to set this value to null. This must always have a value. And so it's not ideal because, for example, it's common in C maybe where a function could return a pointer to an integer that's on a stack, but it could also conditionally at runtime return a pointer to something in the heap. Unfortunately, I have to remove that functionality, but I think the benefit overall is going to be better because since arrays have their sizes known at compile time, and because whether a pointer is on the heap or not is part of the type, and now you don't need to manually talk about pointers because I'm going to be using Rust's ownership model. So you don't have to worry about pointers, but it also means you don't have to worry about deallocation at all. It's just ownership. If you give ownership of something on the heap into a function, then the function will know it's on the heap and know that it has to call free on it at some point. And if it just gets passed along, no matter what, it will never be lost that that thing is on the heap. The alternative I could have done was make everything like a struct and store it at runtime, but that's just additional memory for everything for no reason. This way, I don't have a runtime cost. It's a tiny bit of notation, so the programmer still has a choice whether their stuff is on the heap or on the stack. I don't have to automatically figure that out. The programmer will decide, which is good in my opinion. But they can make something on the heap, and then the language cleans it up for them, and they won't have to worry about deallocation and pesky like null exceptions and like memory leaks and all that. And so I have this notation now. In Rust, if you said A equals B, you're giving ownership of B into A. But for me, I want the equals to mostly be about value. So because if you say, like, to me, I'm thinking of A as a pointer. But if I say like A equals 5, I want that to work. I want that to figure out, okay, this is a pointer, but we should take the value of 5 and put it into a variable and assign it to A or whatever. So if I say A is B, I want to just take the value B and put it into A. And some of this will be automatic. So for example, if B is on the heap and A is on the stack, it should figure out how to copy the value onto A, if it's possible, which is one thing. Now, giving ownership, that is exactly like in Rust. If I give ownership of B using the $sign, I like the $sign as this because it's sort of similar to the ampersand, just visibly, but also $sign is good because it's like money, and you use money to buy things and become an owner of that thing. So to me, it makes sense conceptually. If you see a $sign for ownership, it's like, okay, that's reasonable. Also, sort of in Bash, how like $signs, they kind of mean more value rather than the variable, but it's sort of like associated. So I'm okay with doing this. And then you can pass ownership into functions. You can also use the ampersand for like references and stuff. I haven't fully figured all that out, but this is sort of the baseline for how it's going to work. I'm going to use very similar function notation to Kotlin, except instead of using another colon over here, I'm going to use Python's sort of like arrow syntax, because to me, that just reads better and makes more sense. I think if there's a colon here, it ends up, there's too many colons, like visibly, and it like doesn't look good on your eyes to me. Also, this code is not valid, it's just examples. So if you give ownership of like an int on the stack to an int on the heap, or say you give ownership of an int on the stack to a real on the heap, I think it should just figure out how to convert it and then not allow the first one to exist and then make like a new memory on the heap and manage that by itself. I think that's how I'm going to do it. But that's sort of my current state right now. I've remade the lexer in Kotlin. I need to go into here. My lexer's done, and I've recently started making my nodes for my parser. I guess I didn't commit that yet, but that's okay. Lexer is mostly the same. It's very similar to the one I've had for a very long time if you look through my code, because it's a pretty good way of doing it, in my opinion. And I don't think there's much more for me to ramble about. There's a lot of decisions I still have to make, and I still have to figure out how my publisher is going to work. But I think now that the types are so much simpler, it should be easier to solve. Also, just writing in Kotlin is such a dream compared to C++. It's really just so much better of syntax. I've yet to make a README. I'll do that once I've actually figured stuff out. But I plan on keeping these sort of documents, and I want to make better documentation as well once the language gets more fully featured. Statements. Have I looked through statements? I just started sort of drafting some loops and things. But I think that's going to be it for this devlog. This is mostly just catching you guys up on where I am. If you've actually been listening to this, props to you, because this was some crazy rambling. But if you're interested in this and you want to see more of my progress with this language, just let me know and I'll make more videos. Maybe I'll do some coding ones where I'm actually developing code for things, but it's mostly I just need a place to sort of talk about the design of this. And the good thing about this video is I don't remember all the decisions I made early on, but now that I'm making decisions here, I can sort of record them forever for me, if for no one else. Some of this is like really nice code, in my opinion. Okay, I think that's going to be it. I'll remember to, I think, link all of these repositories in the description. And that's probably way too long of me talking, so I'll see you guys in the next video if I make another video with this topic. See ya.